Hello there, another fantastic problem today, number 69. We're going to be doing task scheduler. In the task scheduler problem, we are given a bunch of tasks and we need to find out how long it takes to process all the tasks given the idle time needed to process a single item. So suppose we need to process an A. We need to wait 2 turns before we can process an A again. So basically, say the CPU time here is say 1. The CPU time it needs to be 3 before 4 needs before it can be processed. So basically, this is 1, this is 2, this is 3, and if it is 3, then after 3, then we can go back into the processing task and we can process it again. So we just need to take it out of the task so that we can bring it back in later. So that means that we don't even so we don't even need to store tell exactly what task how it will be performed. We just need to know the number. One thing is that let's say if we want the items, we can just store it and then bring it back, store that result, and see every single pop, and then push it into a result, and then send it back out. Anyways, the point is, what we're gonna do is basically count the number of characters and see the ones that the most count and start with those first. The reason for that is because we wanna, we want to balance out the number of items for each item so that we can reduce the amount of idle time, because with more balance, we don't end up with a single type of we want to end up with the most amount of types of letters so that we can process them at the optimal time. Anyways, let's just get started. I think with that, we understand that the problem is to get the counter so that we process the one with the most counter. We understand that means we need a heap. We need a heap so that we can always get the highest item in our heap. We don't want to sort this every single time. And the third, we know that we need a queue so that we can store the item so that we can use it for processing later. So 1, counter, 2, heap, and 3, we're gonna use a queue so that we can store, and we need a timer. Okay, so I think those are all the tools that we need to use to solve this problem most easily. So let's start by doing the counter. So the counter is going to be count of let's say the task. So we know how many counts per an item, and then we can heapify. So let's create this heap. Max heap equals count in for count in counter dot values. Perfect. With that, we have our max. We need to max heapify our max heap, and we're good to go. Oh, right, one more thing. We can't use a max heap unless we do a negative, because there's only min heaps available in Python, and the max heap functions are not completely usable. Okay, with that, we can set our CPU time to 0 because we have not processed anything yet, and we can create a queue so that we can remove items from the front and store them in the back. So with that, we can do while we have a max heap. That means while we have task, and or they're in the queue right now and we're waiting for items to be processed again. So then with that, we can process our CPU time plus equals 1. And if there's items in our task, we can start processing something. So counter equals 1 plus the heap queue, not heap pop, of the max heap, because instead of subtracting, we're adding because we're trying to get to 0. So if there is a counter is above more than -0, we don't want to add anything above that, right? So we're going to append that counter and the CPU timer, CPU time plus n. That's when we're going to get it back later. And with that, let's check if there's anything in the queue right now. Even if there's no max heap, let's restore reuse count, and let's do reusable reuse. Let's call it reuse time. Time equals queue of 0. That's our first item. So if reuse time is equal to the current CPU time, that means we need to reuse this. So that means we have to pop the item. So push the item in queue, not heap push. We need to push the reuse counter. That means we can reuse this item now, and that also means we need to pop this from the queue dot pop left. So with that, I think we are done with that, and we just need to return the CPU time. Oh, right. We need to heap push the max heap. Good, and let's submit. Perfect. Timing wasn't too good on this one, but this is I think a very good solution, given the problem that we had. And it's a very enjoyable problem to think about, like the timing. That's one factor. The queue to store the item, the abstraction needed to abstract the counter away from the item, and determining what we actually need for the particular problem, and then getting the heap. If we really wanted the result, like we really wanted to see like the item that we're going to be using, how would we do that? I think that is a good problem, a good question. Suppose that we do. I think we need to store that item in here somehow, in the max heap. I'm not sure how. Max heap takes integers. It doesn't take items. So I'm not sure how that would be done. Yeah, not sure at all. I guess we won't be using a heap system. I guess we'll be using a sort system instead. And we would instead of just grabbing the last item off of the sort after sort, and it will take a little longer. I think that will be what we need to do. And after sorting by the first item of the object that we will create, then we can pull out the results. But all we wanted here was the count, so that's what we did here. Alright, so I hope you learned something today. If you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.